Bismillahirrahmanirrahim. Assalamualaikum and good day everyone. So we are on chapter 11 entitled as Angular Momentum. So in previous chapter, we've done our discussion on linear momentum, right? So now we are going to take a look on the angular momentum. Okay, so before we discuss on angular momentum, the most basic and important part of the angular momentum actually torque. Previously, we've learned about torque, okay, in terms of meaning of it, right, application of it. Directly, I told you that torque is equivalent to RF sine theta, if you still remember. But now, okay, we are going to take a look on torque again, but in different approach by taking a look into method of vector product. Okay, by definition, if you have an object having R position vector, okay, and applied to it F in terms of angle is phi, okay, so now tendency to rotate about a fixed point, which is point O here or origin here, due to the applied force, okay, at certain position, okay, R, now is defined as torque is equivalent to R cross F. Okay, so it must be from R position vector cross the F. This is the definition of torque. Okay, magnitude of this torque is equivalent to RF sine phi. Phi is the smallest angle between the R and the F. Okay, and our torque is lying on the third axis. Okay, since the R and the F within the XY plane, okay, as mentioned before, torque is on the z-axis. Alright, we will take a look in detail on how to determine the direction of the torque. Alright, so let's learn more on the vector product. Okay, so for example, here we have C is equivalent to A cross B. Magnitude of C is equivalent to AB sine theta. The theta must be smallest angle between these two vectors. Right. So put your finger on along A. Okay, since it's A cross B, right? So place your fingers along A and then grabs towards the B. Okay, grabs towards the B because A crossing to the B. Right, so your thumb is pointing to the direction of the C, the product of A cross B. Alright, if you put it wrongly, if you put it in reverse, means that B cross A, okay, you have to place your finger along B firstly and then cross towards the A. So you will get your direction is downward. Your thumb is pointing downward. It means that it's negative of C. This is on how to determine direction of the product between the C when you have A cross B. Right. So the product here, C here, is a kind of vector. Okay. This is opposite to the one that we discussed in work done. Work done is defined as F dot R, isn't it? Or also known as F dot D. The magnitude of work done, where the F is vector, the R is vector, or you put it in D. Okay, where magnitude of the work done is magnitude of the F, magnitude of the R, okay, cos theta between them, isn't it? And work done only scalar quantity. Okay, but here if you have torque is equivalent to R cross F, okay, torque is a kind of vector. It has magnitude, it has direction. Okay, that is the difference. For torque, magnitude of the torque just now is magnitude of the R, magnitude of the F, sine theta or phi. the angle between them. Alright, the vector product. Properties of vector product. Okay, if we have A cross B, okay, for this example, okay, is equivalent to negative B cross A. Madam already told you slightly on the display explanation. Cut this part. The vector product. Properties of vector product. If you have A cross B, this is equivalent to negative B cross A. Right. A cross B will be 0 if the A is parallel to the B, or it means the theta is 0 degree, or anti-parallel to the B, where we have theta is equivalent to 180 degree, because sin 0 or sin 180 degree give you 0 value. So goes the same to A cross A will be 0. Goes the same to the B cross B. Okay, or B cross B also give you 0 because they are in the same direction. So the angle is 0 degree. So if you press your calculator, sin 0 give you 0. If the A is perpendicular, okay, to the B, right? So means that theta is 90 degree. Then the magnitude of A cross B will be AB. Okay, where is the sin theta? Sin 90 give you 1. You do have sin 90 here, which the value of it is 1. Right. Next one. If you do A cross parenthesis B plus C, okay, you may rearrange this into A cross B plus A cross C. Means that you have to solve A cross B, whatever the product is, and then after that you solve A cross C, whatever the product is, and then finally you're going to add up them. This product add with this product. Okay, next one. If you want to do the differentiation between A cross B to the respect of time, for example, you may rearrange of this into dA over dt cross B. Do the differentiation, and then after that do the cross product between A and B. Okay, plus A cross dB over dt. Okay, you may rearrange it into this method. Okay, so the vector product in terms of IJK, right? So since just now, okay, when the angle is 0 or 180 degree, okay, so means that I cross I or J cross J or K cross K will give us 0. Okay, but if you have I cross J, okay, will give you K, isn't it? I cross J, the answer is K. This is similar to negative J cross I, right? So remember, we can rearrange, okay, the last one become the first one, provided that we put negative sign on it. Okay, so again, I cross J is equivalent to negative J cross I, which is equivalent to the K. So I cross J, the product is K. Right. How about if you have J cross K? J cross K, the product going to be I. See? Okay. Which equivalent to negative K cross J. Right. Next one, K cross I. The product of it is J, K cross I, equivalent to J, which equivalent to negative I cross K. Okay, how about if we have J cross I? If we have J cross I, it will give us negative K because it's cross J cross I. It is in opposite direction to this drawing or method. So J cross I give us negative K. Goes the same to I cross J. By right, K cross I give us positive J. But if we put it I cross K, we will have negative J. Okay. So if K cross J in opposite direction to this, okay, k cross j will give us negative I. Right. So let's take a look on how to do the A cross B if you have ijk term. Okay. So let's say, remember this? Okay, this technique. Okay, just now. Alright, so let's say we want to determine, okay, the product for I. Okay, close this part. Okay, close this part. Imagine you can close this part. Take your ruler or you use your finger. And then this is the first step. The second step, do the multiple process between J to K, because you want to have the product of I, right? So it must be J cross K. So begin with J. So you're going to have, all right, here is in terms of writing of it. Here is the process of it. Okay, AY BZ. AY BZ minus step 3 AZ BY. Okay, this is a product for I. Okay, because remember J cross with a K will give us I. Right. So again, okay, we are going to repeat the same step for the J. Right. So for the J, we are going to sort of close the J. Okay, now we are going to do, this is our first step. Okay, we want to have the product for J, right? So second step, what we're going to do, we are going to cross between, okay, to have J, you have to do K cross I. So we begin with the K. Okay, AZ cross with the BX. AZ BX. So here, okay, AZ multiple with the BX. This one. Right. Next, minus with, okay, AX times with a BZ. This one. Okay. So this is on how to do the calculation, okay, when you have to figure out the G, the product for the G. Okay. Then next step is for K. Alright, for K, right, for K, now to have K, we are going to do I cross J. Okay, I cross J. Okay, I cross J. So what are we going to do? First thing first, sort of, we are going to close our K. Okay, then we are going to do the multiple process. Firstly is AX multiple with the BY. Okay, and then this one, the green color. After that, okay, minus with AY cross with the BX here. So we will have our K product. Right, direction of torque vector. Okay, so again, place your 4 fingers, okay, along R, okay, and then grabs along or towards the F. Okay, grabs towards the F. You actually may rearrange the F here. Okay, force can be shifted as long as you remain the magnitude of it, the length of it, and also the direction of it, which is the angle. So this is simpler, right? So place your 4 fingers along the R and then grabs towards the F. Okay, you will see your thumb is pointing upward like this. So the direction of your thumb will be the direction of your torque. Okay, and always remember that the torque, okay, the product of the cross product between two vectors always lies on the third axis. Okay, not within the xy axis like this. Where we have the two vectors here. Okay, when we do the cross product between R and F, the vectors lies on xy plane. The product of it will be on the third plane. Always remember that. Alright, now let's take a look on example 11.1, the vector product. Two vectors lying in the xy plane are given by the equation of this: A equivalent to 2i plus 3j and B equivalent to negative I plus 2j. Find A cross B and verify that A cross B equivalent to negative B cross A. Alright, let's take a look on A cross B. So this is our A and here is our B. Okay, so cross means similar to multiply, isn't it? Multiple. So sort of we are going to open up the parentheses. So we are going to do 2i multiple with negative I plus 2i multiple with 2j, right? And then 3j multiple with negative I and plus 3j multiple with positive 2j. Alright, so if we look at this, I cross I will give us 0. So the product of this will be 0. I cross j will give us positive k, right? So 2 times 2, 4, positive 4k, this one. Right now, j cross with the I. J cross with the I is opposite to this direction, isn't it? Regardless whether this one is positive or negative. The thing is right now, j is the first one. Okay? And then we have to cross the I. So j cross I. So it means that we are going to have opposite direction, right? Negative k. Okay. So we have 3 times negative 1 will give us negative 3. But don't forget our answer must be negative of it. So negative of negative, you will get positive 3k. Right? Then j cross j will give us 0. Right? So we have 4k plus 3k, we will get 7k. Okay, now we are going to proceed to B cross A. Okay, so this is our B, then cross with the A. Right? Again, we are going to repeat the same method. Sort of, we are going to open up the parentheses. So I cross negative I cross positive 2I plus I negative 1I, okay, multiple or cross with the 3j. And then 2j cross 2I and then 2j cross 3j. Okay, so let's take a look at the product. I with I cross I give us 0. Okay, I cross j will give us positive k. J cross I in opposite direction will give us negative k. Right? And then j cross j give us 0 again. Right? So, okay, here we have negative 1 multiple with 3, we will have negative 3. Negative 3, but your answer, okay, positive k, right? So negative 3k. 2 times 2, the answer is 4, positive 4 by right. But you have to negative of your answer. So negative of positive 4 will give us negative 4. So from here, if we add this up, you will have negative 7k. So means that, okay, it is true that negative of B cross A, it means that negative of whatever we have in hand just now, B cross A, negative of negative 7, give us positive K. So means that A cross B is equivalent to negative B cross A. In our case, it's positive K, 7K. Alright? Example 11.2, the torque vector. A force F equivalent to 2I plus 3J Newton is applied to a rigid object that is pivoted about a fixed axis aligned along the z coordinate axis. The force is applied at a point located at R, equivalent to 4I plus 5J meter relative to the axis. Find the torque applied to the object. Right. So as we know, the definition of torque is equivalent to R cross F. Okay, so we have our R here and here is our F. Don't forget this method, right? And then now we are going to do the cross. Okay, so for here we have 4I multiple with 2I, the product I cross I 0, give us 0 here. And then 4I multiple with the 3J. Okay, so I cross J, positive K. So we have 4 times 3, 12K, and it's positive. Then next, 5J multiple with 2I. Okay, so J cross I, isn't it? In opposite direction to this. Then you will have negative K. That is why negative 10K. Then next is 5 cross with a 3J. J cross J equivalent to 0, give us 0. So product of this is actually 2K Newton dot meter. This is the answer for our torque equivalent to R cross F. Analysis model, non-isolated system, where we're going to focus on angular momentum. Right, take a look on this diagram. Okay, imagine a rigid pool sticking up through the ice on a frozen pond, as shown here. From the left, okay, of this figure, a skater glides rapidly along a straight line, okay, towards the pole, aiming a little to the side so that she does not hit the pole. As she passes the pole, she reaches out to her side and grabs it. An action of that causes her to move in a circular path around the pole, right? Just as the idea of linear momentum helps us analyze a translational motion, a rotational analog, which is angular momentum, helps us analyze the motion of this skater and objects undergoing rotational motion. Right. In chapter 9, we already take a look on this, okay, where net force is equivalent to rate of change of momentum. Okay, let's recall rate of change of momentum is actually change in m to the respect of the time given. Alright, so talking about torque just now, since the skater just now is moving in a circular path and it's rotating about a fixed point, which is the pole, the woman experiencing torque. And we know that torque is defined as the cross product between R and F. Okay, so our F just now is the R cross dP over dt. Okay, so how to solve this one? Okay, we may put it like this. Okay, it could be the one that going to be changed is R, or the one that going to be changed is P. So if we want to solve this one, it will be like this one. Okay, dr over dt cross P plus R cross dP over dt. This is a formula on how to solve it mathematically. And we know that dr over dt is actually V. Okay, because R is position. Change in position over change in time is actually velocity. From chapter 9, we already learned about linear momentum is defined as the product of mass with the velocity. So, mass is scalar quantity, has no direction. So, the direction of the P must be according to the direction of the V. So, means that P and V must be in the same direction. Whenever you have two vector in the same direction, the angle between P and V is parallel, okay, or 0 degree. So when we do cross product between two vectors having 0 degree or parallel in position, okay, the product of this going to be 0, because by definition of cross product is going to be RP sin theta, if you still remember. So sin 0 give us 0 value. Goes the same if they are in opposite direction or anti-parallel. So since 180 degree give you also 0 value. So this side going to be 0. Okay, therefore we are left with this part, R cross dP over dt. Okay, so from here, the original one of it, okay, torque is equivalent to R cross dP over dt. Okay, this part already 0. Therefore, okay, we are left with this, R cross dP over dt. Right? So then, talking about torque now, we can rearrange, okay, the equation of the torque in terms of dr cross P over dt. Right, so in terms of sketching, this is where we can visualize our R and P, the momentum of the object. Okay, and phi here is the angle between the R and the P, and the angular momentum, okay, the angular momentum or change in torque just now is equivalent to R cross P. So let's take a look on this in detail. Right? The instantaneous angular momentum, symbolized as L, okay, of a particle relative to an axis through a chosen origin O is defined by the cross product of the particle's instantaneous position vector R relative to that origin and its instantaneous linear momentum P. Okay, so angular momentum is defined as R cross P. Okay, why is it named as angular momentum? Because, okay, the object having R and the object is moving with certain amount of velocity. Okay, so now our equation of torque can now be rephrased in terms of sum of torque equivalent to dL over dt. Similar analogy to the sum of force equivalent to dP over dt in our previous topic. Alright. And from here, okay, what is our L in terms of magnitude? It is going to be mvr sine phi. Phi is the angle between V and R. Or here is actually P, right? MV here is P. Okay, let's take a look on this diagram. The angular momentum L of a particle about an axis is a vector perpendicular to the both the particle's position R relative to the axis of it, relative to the axis, and its momentum P. So both of these vector contribute to the amount of L here. Okay, L is actually a cross product between R to the P. Okay, so whenever R and P is parallel, okay, means the angle is 0, or anti-parallel means the angle is 180 degree, angular momentum going to be 0, because sin 0 or sin 180 degree give us 0. Whenever the R and the P is perpendicular to each other, it means that the angle is 90 degree. So the L going to be the maximum it can be, because sin 90 give us 1, and maximum value of sin theta or phi here is 1. So this value gonna be maximum of it. So we are left with MVR. How about the unit? The unit going to be kilogram dot meter per second dot meter. You can imagine from that and simplify it. Okay. So let's recap. Okay. Sum of torque is equivalent to dr cross P over dt. R cross P itself is L. So we're going to have dl over dt. Okay. And in terms of magnitude of the torque, okay, is equivalent to magnitude of R, magnitude of P, sine phi. Okay, and our P is mv. Okay, so now we can have a conclusion that sum of torque is equivalent to dl over dt, which equivalent to rmv. The same with this. Okay, if it is parallel, then 0. Sin 0 give us 0. If it is perpendicular, sin 90, it give us 1. So we will left with RMV or MVR, either. Right. And then how to determine the direction of the L? You have to use right hand rule. Okay. Place your 4 fingers along R. Okay. And then grabs towards the P. Alright. Grabs towards the P. Then your thumb will be pointing to the direction of the L. This is grabs rule or right hand rule. Example 11.3. Angular momentum of a particle in a uniform circular motion. A particle moves at constant speed in the xy plane in a circular path of radius r, as shown in the figure. Find the magnitude and direction of its angular momentum relative to an axis through O when its velocity is v. Right? So as we know, our L is defined as MVR sine theta. So since the V and the R is perpendicular to each other, because this is VT, right? Tangential velocity. So C90 give us 1. That is why our formula will be MVR. Now, let's have a recap about our chapter 9. Okay, sum of F external is equivalent to dP total over dt. What does that mean by this? Okay, means that we are going to add up all the momentum of the system. Okay, so goes the same to the angular momentum. Okay, angular momentum total means that we have to add up angular momentum for object 1, object 2, up to object n. Right, so it means that we are going to calculate the sum of the angular momentum for every single object within our system. Alright, so to have dl total over dt, it's equivalent to sum of dli over dt for I items, which equivalent to sum of torque for all item or object within our system. Now, angular momentum of a system of particles. Okay, we can have just now sum of torque external equivalent to dl total over dt, which is an analogy to the sum of F external equivalent to dP total over dt. Right, where we can rearrange this item or formula into integration of sum of torque external, dt is equivalent to delta L total. So, to imagine this equation, let's take a look on this model. Okay, so if we have a system, this is the boundary of the system, right? Within the system, we have angular momentum, right? So, and we have to consider external torque. The external torque could be done into the system or out of the system. The rate of change in the angular momentum of the non-isolated system is equal to the net external torque on the system. That is the meaning of this equation. Right. Example 11.4. A system of objects. A sphere of mass m1 and a block of mass m2 are connected by a light cord that passes over a pulley as shown in the figure. The radius of the pulley is r and the mass of this thin rim is m. The spokes of the pulley have negligible mass. The block slides on a frictionless horizontal surface. Find an expression for the linear acceleration of the two objects using the concept of angular momentum and torque. So if we refer to this diagram, this object is moving to the left, which is linear motion or translational. And this object is moving downward, also linear or translational motion. The one that going to rotate or having torque to be considered is actually the rim here. Okay? Right. So let's figure out the L for the system that we have. Okay? L is defined as M1 VR plus M2 VR plus MVR. Okay? Where we can factorize, okay, V and R outside because all of the object going to move with the same V, okay, and the radius here also the same, right? So sum of the torque external is equivalent to dl total over dt. dl total we already figured out it here. All right, so what torque exists? The torque exists here, okay, due to the M1, the weight from M1 that going to cause the rim to rotate. Okay, so the force that causing the torque exists here is actually the weight of M1. So the weight of the M1 times with the perpendicular distance to the axis of rotation. Here is the axis of rotation. Okay, the weight, and here is the R, and it is perpendicular. Okay, so that is why we have mg, m1g, r supposedly sine 90 give us 1, which equivalent to d L total. Our L total is M1 plus M2 plus capital M, okay, times with VR, right? So we can have here, okay, dV, the one that going to be changing is V, right? This is a constant, this is a constant, all of these are constant. So we're going to have M1 plus M2 plus capital M R dV over dt. Okay, so R here can be cancelled out, right? So we are left with dV over dt is actually acceleration. So acceleration is equivalent to m1g over m1 plus m2 plus capital M.